so you can follow. Fred, can you hear me?
Yes, I can hear you.
Yeah, you can take over.
Okay, thank you, Iwanson. Hello, everyone. I think the number is too low for today. I don't know what is happening. Hope you have the rights to welcome or to invite, or does it need anyone to admit people? Iwanson?
No. Mtu anaingia tu direct.
Oh, hey, it's okay. That's okay. Okay. Welcome. Let me see how many have been here since day one, since the first class. By a show of hands, raise up your hand. One. Who else? Since day one. How many? How many? Two. Anyone else? Three. Very nice. Who else? Four. Five. Two, three, four. Four people. Who else? Okay. Okay. Let me see. Okay. Don't lower your hand. How many have been here since the second day? I think for the first day we have 6 people. Don't lower your hand. How many have been here since the second day? Okay, 7. Only one person. Okay, 8. Carolina. 9. Okay. So I think as we continue, you can still invite. You can call your friends and you can send them the link so that they can join. Okay, how many have been here since okay, today? For today only. Only for today. Today is your first day for you to join the meeting. You are joining the meeting today. Okay, let me confirm first. Evanson, are we live on YouTube?
No, for today we can't make on YouTube. We have some challenges.
Okay. No problem. Let me do something. Let me see if I can record from my side.
Yeah.
I'm not sure, but let me just try. Okay. For those who had risen their hand since day one, they have been here. Okay, they can share. You can share what have you been able to learn, and yeah, what have you been able to learn since the first day? Something which you didn't know, and now you, at least you can say. Is there anyone? Someone, anyone you can. As I am trying to figure out how to. Anyone?
Ningejibu swali but currently niko kwa barabara saa hii natembea. I don't know.
Huyu ni nani anatembea? Oh, haina shida Ivanson.
Yeah, so it won't be that efficient,
Yeah.
but I can still try.
Yes, no problem.
Yeah, so for those who are not with us, we started these sessions on Monday, and we did the introduction to some electronics, those gadgets zenye tutakuwa tunatumia in IoT projects. And our facilitator of the day Fred ama Mr. Arduino. I'll share the link to his TikTok account so that you can follow him. He took us through all those. He showed us those hardwares that we need to use. In IoT, mostly people use there is the hardware, there is the software part of it. Yeah, and he showed us these sensors, akina Raspberry Pi Pico, there is the ESP32, and everything, akina Arduino and so on. Everything has its own purpose. Kuna ile kazi kitu hufanya. So we pass through tukafunza hizo akina resistors vile zinafanya, but that theory is on YouTube. For yesterday is the day we did our first practical, and our practical was kutumia Raspberry kulight an LED. So we were using Python for that coding part, and the IDE we were using, it's wow, I'm forgetting the IDE inapotea. Uh-huh.
Dhoni.
Fred,
It's
can you
Dhoni.
the name of the IDE?
Dhoni.
Oh, Dhoni, yeah. Dhoni is the IDE that we were using. Tunaandika code, tuna connect, tuna configure, and after running, we could see that the Raspberry could light the bulb and shut it after the time yenye tumeipea. Yeah, and hapo ndo tulifika. Yeah, for today we will continue.
Nice. That was nice. Anyone else? Anyone else? Mohid Said. Mayor, Brian. Let me see. Who else? Anyone else? Even yesterday, what did you learn? As I'm trying to see if I can record screen recorder. Anyone else?
Mine as a takeaway home was how to use the Thorny space in terms of keying the code and also seeing the bulb getting to light the LED. So that is the standout for me, and I'm hoping to engage with this so that we can maybe run different programs, or maybe come with with an innovative ideas in terms of how to execute uh, programs that they can be run through the phone.
So,
So I'm really looking to that.
was it your first time to interact with programming? And yeah.
No, it's not. I work with Tech Kids Africa, and we usually interact with students. We train them on robotics. But the only challenge that I wasn't so familiar with the phony. But
Oh.
I have been having a theory. So I was training them on the theory part, but I have a colleague training them on the practical part. So I wanted to at least upscale and learn more about the phone so that I can also take up the challenge.
So in I think I've heard of Tech Kids. Which language do you use to program the robots?
The MicroPython.
For what board do you use?
We use we had Arduino,
Mhm.
but right now we are working with the Raspberry Pi. So it is we are using the Raspberry Pi microcontroller.
Or the same as which we are using now?
Yes, yes, and the same one.
Okay. So which age group do you usually interact with mostly?
From 7 years to 18.
7 to 18.
Yeah.
Oh, it's okay. It's okay. Okay. Thank you for
Okay,
your
sure, sure,
input.
sure.
I'm still trying to see if I can record. Okay, just a minute. Anyone else? Anyone else? Okay. What about those who are joining from today? Like Rebecca. Maybe they can unmute and tell us their objective, or maybe what they at the end of the lesson or the course, what they want to achieve. Rebecca. Okay, I think now I'm able to record. Okay. Okay, just a minute. Okay, I think now I'm able to record. Microphone, start recording. Okay, welcome guys to this day. It's day 3 session, whereby we are going to continue learning programming, but we are not necessarily learning a new programming language. We are learning Raspberry Pi MicroPython for Raspberry Pi. So in case you have any question, you can interrupt me at any time. Okay, so let's start. Let me do a quick recap of what we have done since day 1, but this should be quick one. Okay, we have been learning, for the sake of those who are attending for the first time, we have been learning about Dhoni IDE. This is the compiler which is used to code. For programming, you have to have a compiler for you to upload the code to your boards. Is there anyone raising their hand? What was that? Okay, I think Ivan will sort you. So just a minute, let me leave the related. Okay, so if you want to learn coding, and for instance we are going to learn MicroPython, you have to have basics of at least one programming language, like Python, C++, but now MicroPython is under Python. So if you have knowledge in Python, I think you are good to go, but not necessarily you need to have knowledge, but you can if you know how to write the hello world in Python, you are good to go actually. So let me show you something. Dhoni, using Dhoni IDE. So IDE stands for, someone should type there in the comment section, what does IDE stand for? So we are going to use IDE. IDE is the program which we use to write our code and upload to the board. So for instance, I am using this IDE called Dhoni. I don't know, is my screen visible? Someone should react. Yes, Stella Kabura, it's true. Is my screen visible? Is it showing? Okay, nice. Thank you, Stella. So the ID, this is the ID, and the prerequisite for you to learn MicroPython. Actually, MicroPython is very interesting, and like I cannot compare it with other languages like Arduino. But also I love Arduino, but I love MicroPython more. So I said you just need to understand the hello world in Python, which is usually very simple. You just need to understand the print. This is the hello world in Python. For you to run hello world in Python, it's very simple. But now, just a minute. Can anyone tell me why my run button is not active? Anyone try? If you have been in the past classes, you can I think you know why it's not active. Why? Anyone trying? You are not connected to Raspberry Pi. Sure, it's true. So that is what I'm doing now. I'm connecting the Raspberry Pi. This is the Raspberry Pi Pico. Okay, we have you must say which type of Raspberry Pi you are using. For me, I'm using Raspberry Pi Pico because in Raspberry Pi we have different types of board. We have so I don't need to press and hold this button, because this is the second or third, not the first time which I'm using this Raspberry Pi Pico. So it's already set to go. I just need to connect. I've connected my Raspberry Pi board. Then we go back to the IDE. We hit on run configure interpreter. Then we have to select the port. You see this port? This is the port which we have connected our Raspberry Pi Pico. So I click on that port, then I select board number 18. Then after that, okay, we have selected this MicroPython, MicroPython Raspberry Pi Pico. Okay, we are coding in MicroPython, the language, and the board is called Raspberry Pi Pico. So I select. Then we are going to get a message here. According to the message, we can say if we are good to go, or we have some error. So if you get these three arrows, I think you are good to go. Now we can print hello world. World is not written this way. How do you write? Oh, sorry. Yes, hello world. Then after that, we just need to now understand the syntax. I told you all programming languages, they have the same structure but different syntax, whereby the structure of all programming languages is called DAE, whereby in D it's called define. In A it's called, sorry, it's assign. In E it's called execute. Yes, so you have to follow this structure in most of the programming languages. So you have to define and assign, then you have to execute. Like in maths, this is for those who don't have any basic in programming. In maths, we usually have there's a chapter which was called it's still called what is it, algebra, whereby you are given something like you are told a equals to 3, you are told b equals to, okay, let me do a good job, equals to 3, B equals to 7, then you are told C equals to A plus B plus, how do you write plus B? Then you are asked, what is C? Someone should type there in the comment section, what is C? Washington Kimani, welcome. What is C? What is C? 10. Okay, C is 10. Nice. Yes, it's true. It's A plus. Let me ask now. Let me do this. A. Let me change. C equals to 21. D equals to 13. E equals to A times F. What is E? What is E? Someone should type there in the chat. Let me see. Anyone? What is E? You're now quiet. Stella, what is E? Or rather, what is the answer? That should, Eugene, are you sure? That should be an error. There is no F. Anyone else trying? What is E? Okay, error. Dan Dirangu. Still. Okay. E is A times F. It's true. Now you are repeating what I said here. It's like asking someone who is a boy. Then they tell you a boy is not a girl. So, okay. So it's not possible. It's not possible, but not according to not according to maths. According to maths, maybe according to programming, it's not possible. Who can tell me why it's not possible to get E? Why? Why is it impossible for us to just let me? Why? Why? It's not defined. Nice. I think Dan, you got it right. E is what is not defined, or F is not defined. Sure. Stella and Eugene, it's true. And Dan, F is not defined. So you have first to define. We said you have to define. Actually, it's okay. Also, you are wrong. You are right, but also you are wrong. Can you? What else? What else? You are correct, but your answer is not full. Okay, let me just say it. We have to define and assign. Actually, it's not also assigned, because if we define the F here, F, and we don't assign it to anything, it will still become an error. So, but we need to do the both. We have to define, assign, then execute. Here we are executing now. We are executing. I think I'm clear. Is there any question? No question. Okay, let's head to Raspberry Pi. How many have tried to work with Wokwi or any online simulator? Let me see by a show of hand. Jefferson, how many have tried to work with Wokwi? I told you to try and see if you can. Jefferson said, "I'm right." Yes, Mohammed Said. So you have tried. Nice. How was it? So pardon?
It is good.
Yeah. Okay. Okay. Who else? Okay. Okay. Today we are going to remind ourselves about the blink code, whereby we said for us to write the blink code, we need to import several libraries. So we say from machine import pin. So ela ona ingia meeting imeanza, ishaanza. Okay, sorry for that. Import pin. So we are going to also import time. Then from there we are going to create an object called LED. You can also call it any name. Let's say we can call it light, but we have rules governing that. Light equals to pin, pin into brackets, we put it to pin number 25. Then is it input or output? Pin dot out, because it's output, we are going to say pin dot out. So then we are going to create an infinite loop, a loop that will never end. Sorry, while true. Sure, while true. Then we are going to say, we are going to turn on the light. We say light dot value. Then we pass 1. As you know, in binary, actually this is binary whereby 1 plus 1 equals to 0 carry 1, or 1 plus 1 equals to, actually 1 plus 1 equals to 1 0. So then we say time dot sleep. We give it, let's say, 1 second. So light dot value, we give it 0. Time dot sleep. Okay, that's my code. So that is the blink code. Is there any issue with the code? Is there any issue with the code? Is it correct? Is the code, will the code work? Let me see reactions. If it's okay, you can do thumbs up. If the code is okay. If it's not okay, thumbs down. Let me see. It's okay, Anthony. Who else? Is it okay? It's either okay or not okay. It's okay not to be okay. Is it okay, Stella? Is it okay, Mohammed? Said? Is it okay? Who else? Eugene? Yes, Moha. Eugene Hunter? Is it okay? Dan Dirangu? Is it okay? Collins Davis? Is it okay? Who was that? Maybe you can repeat you can. Yes, Eugene, it's okay. Stella, is it okay? Manu, yes, it's okay. Okay. Stella, you don't want to vote. Oh, it's okay. So I think if you, okay, our code is okay, but it will not blink. Actually, it's not okay because we said it's a blink code. So we have different types of errors. We have a error called logic error and syntax error. This is a logic error. Okay, the LED will turn on in this line. Sorry, in this line, LED will turn on. Then it will wait, still turning on for 1 second. This one. Then in this line, the LED will turn off, and we are telling it to turn off for 0. second. Actually, it will not turn off, because after this it will go to this other line. So I think this code will just turn on the LED, it will not blink, because let's say we put another value here, we have to put a reasonable value like 1 to tell the LED stay off for 1 second. So that is called logic error. It will not give us the intended output, but I think the syntax is okay, we have typed well, but it's logic, our thinking. Okay, is there any question up to there? Litmus. Okay, Davis. No, Davis, you are late. You said it's okay. Said it's okay. So you are wrong. Okay, let's continue. Let's continue. So today let's do a project. I think everyone should try. If you have a computer there or your phone, we are going to make it as interactive as possible. So let me share my screen. I need to share my screen. But before that, let me open walkwe.com. So sharing my entire screen. So open walkwe.com. How many people are able to open on a new tab? You...
Fred, do you mind sharing your screen?
Oh, sorry. You can't see my screen.
Yeah.
Oh, how now? I can see my screen now. Oh, you can. Oh, let me see. Is there anyone who can see my screen? Anyone? I think Evans can see my screen. Even me, I can see my screen. I think you have issue on your side. Maybe you can try, because my screen is visible, because I'm sharing the entire screen. Actually, you can see even the meeting screen. So because the rest can see my screen, let's continue. Yes, thank you, Eugene, for confirming. Okay, someone should open the Raspberry Pi Pico. Okay, the walkwe.com, then head to Raspberry Pi Pico. So you can always start with something like, for example, we have they are like templates which have been done already for you. Maybe you can. I said I'll try and see if I can. Okay, start. We need to. You can also code it in C++, in Arduino programming language, as you can see in this code. This code is for Arduino programming, but now because we are learning MicroPython, we are going to start with this template for MicroPython. As you can see, these are Blink code. These are code with the 8-segment display. It's another code with the NeoPixel ring. I think it's WS2812B. It's a it's a NeoPixel. We have another one with SSD 1306 OLED display. This display, and Raspberry Pi Pico. It's under MicroPython. So can we start? Maybe we can start with a template, like let's say this one. Should we start with this one? Which one should we? Let's try this one and see the code. Okay, this is the code. Let me try and run and see what the code will do. Simulate. Yeah, you can see it's typing Raspberry Pi Pico, and it has started the timer. 6 seconds, after 7 seconds. Also, we can change the text, so you just need to locate the line in the code. Let me see if we can see Raspberry Pi. Let's say we write we replace with what have I done? Where is it? Yeah, this line we replace with, let me write Mr. Arduino. Okay, we have to stop and start simulation and see what will happen. Yeah, Mr. Arduino, I think you can see the Mr. Arduino there. I don't know why the Pico, because of this Pico, it's showing Mr. Arduino. Let me say Mr. Arduino Hapa. Stop and start simulating. So with this code, with this template, you can customize the way you want. Actually, this is the beauty about the open source languages like Arduino and Arduino, because you can find your project which you have idea of. Someone has developed it, let's say halfway. Then you can try and fabricate it to capture your own ideas. So, like for example, you saw what I did there. But for me, I don't. Because we are learning, we don't want to start with the template. We want to start from scratch because we are beginners. So it's still MicroPython. Where is it? Where is it? MicroPython. Yes, but we need a blink. Okay, we can start with this one for blink, but we are going to edit. You can even rub everything. Okay, you can remove this one, but I don't want to. Okay, we have another approach whereby you can say from utime import sleep. Then instead of saying time.sleep, you just say sleep 0.5. But let's just go with the easiest. Okay, number one, we need to add LED. We have different components here, but we are going to use LED. So pick LED and place it somewhere like there. Then sorry, just a minute, let me share the link to some people in the IoT group. So we have picked the LED, so we need to make connections. Let's say GPU, or we want to connect the ground. This is the ground now, so we can choose any ground. Like let me see which ground is here. This is ground, so we are going to connect this ground to the ground of the LED.
Sorry. Excuse me, can you zoom out? You can't see your screen. Girl.
Oh, you can't see my screen. How now? Is there anyone who is experiencing the same issue? Anyone else?
We can see the screen, but we can't fully see it. It's like half. It's zoomed in. You have zoomed in a lot, so we can't see it clearly.
Okay, let me just share what I need to share. Just a minute, let me. What about now? Is it visible?
Yes, much better.
Yeah.
Okay. I think what I've done, I've just made this connection from ground cathode to the ground of the Raspberry Pi. Then we need to connect the LED, the positive of the LED, to the digital pin. Like for example, you can connect to any digital pin, but okay, in practical, don't make direct connection. You need to include a resistor. Let's see, resistor, current. It's called a current limiting resistor. And also you can put the value of the resistor. Actually, LEDs we usually work with 220 or 330, not kilo but ohms. Ohms, nice. So then we need to make the connection from the LED to the resistor, and then from the resistor to a digital pin. Let's say we want to use any digital pin, like let's say we can use GPIO 6 or 2, sorry, GPIO 6. Let's use GPIO 6. Nice. I think we are done by that. So what we need to do, we just need to write the code. Let me zoom in a bit. We're going to write from machine import pin. Then let's just turn on the LED. We create an object. Let's say LED equals pin, then open the brackets. Let's, which pin was that? It was a pin 6, GPO 6, comma, pin dot out. Then we just need to turn on the LED. We don't need to include the, because we don't need to delay maybe. So let's just turn on the LED. So it's, we are going to pass the value of 1. So let me run the code and see if it has any error. Actually, if your code has any error, it will not run. As you can see, we just have how many lines of code? We have only 3 lines of code, and our LED, it's on now. Is there any question up to there? Is there any question? Any burning question? Okay, no question. So let's continue. Let me zoom out. So let's assume we want to connect several components to the breadboard. You know, we will not be able to connect because we have limited number of grounds, which are around, I think we have around 3 or 4 grounds in a Raspberry Pi Pico pinout. So for that we cannot connect more than, let's say we want to connect more than 10 LEDs, because we have over 20 digital, GPL pins, which can accommodate each one LED. But we will be limited because we have a limited number of ground pins in the Raspberry Pi Pico. So what do we do? Is there anyone with a solution? What can we do? What can we do with that? Because we want to connect the more than one LEDs. Let's say, for example, we want to connect 15 LEDs. What can we do? Let me check on the chart. Eugene, what can we do? Okay, let me continue. Let me just continue. So for that, we just need to use something called breadboard. I told you as a beginner, okay, when you are advanced, you would need to learn about breadboarding. It's a prototyping. Actually, breadboard is another name. It's called a prototype board, whereby you just need to test your circuit before you make it the final one. So we have different types of breadboard according to sizes. We have full breadboard, we have half, and we have mini. So I don't know which one. Let's try the full breadboard. It will limit us somehow, but it's okay. Okay, this is the breadboard. Let me just show you how we do it. Let me just zoom in a bit. So a breadboard, it has, I think you saw, I had a breadboard yesterday. Where is the breadboard? But for me, I'm using a half breadboard, this one. Can you see my breadboard? Okay, let me just explain. I'll show you practically. So we have these two rails. Actually, they are connected. You see, these are pin number 1, 2, 3, 4, 5. All these pins are connected internally. Actually, they are connected. The way you can see my mouse moving, all those pins are the same, and they are denoted with a positive. Actually, this line, it shows us that we have some connection in those pins. Actually, they are horizontally connected. Okay, next, you need to know, you see this pin, we are on the second row. You see this pin 1, 2, 3, 4, 5, 6, all of them, they are connected this way. But in this lower part, lower line, and this one, there is no connection between this pin and this pin. Let me zoom a bit. You see this pin, and this one, and this one, and this one, in that line, they are horizontally, internally connected. But you see this one, and this one, and this one, and this one, this line, the whole of this line, they are internally connected. But we don't have any connection between this pin and this one. Am I clear? Someone react? Thumbs up, thumbs down, thumbs up. Nice. Okay, let's continue now. Let me zoom. So, okay. I wish I could use the smaller breadboard, but it's okay. Okay, you see the same thing applies to this one and this one. But now, what is the difference? The difference is inside. You see A, B, C, D, E. They are internally connected. Okay, let me zoom a bit and show you. A, B, C, D, and E, they are connected. If I connect a jumper wire to this pin, it's the same as connecting to pin C, and the same as D, A, and B. Okay, but okay, the same thing applies to the second. Is it a row or a column? The second column, row, the second column. So this one, it's A, B, C, D, E. They are internally connected. Actually, we have a connection. If you measure using your multimeter, you are going to get a buzzing sound. There is a continuity. But now, between this pin and this pin, we don't have any connection. Are we together? Let me see reactions. Okay, Stella, only one reaction. Okay, nice. I think we are good. We are good now. You can. Okay, let's continue. So, I think you are good now. But, okay, between E and F, we don't have any connection. So, here we have a ditch. It's like a disconnect. So, F, G, the same thing applies to these other parts. We have connection here. We have another connection from there downwards, even upwards this way, downwards, but no connection between this one and this one. Okay, is there any question? Any question before we move on? Any quiz? Any question? Yes, you can proceed, Jacqueline.
Can you please repeat that last line?
Okay, just a minute.
On the connections of the pins.
A, B, C, this way.
Yes.
So pin,
So,
yes,
oh, okay, continue.
pin A, you see this
Oh,
hole, it's connected internally with B, connected internally with C, with D, with E, but we don't have connection. You see this E and this other one, we don't have any connection. So these are, they usually go, they are opposite of these. These are horizontal, but these ones are vertical, this way, downwards.
okay.
You understand?
And yes, and on the code line 2, would you please explain that line 2 on the code?
Which one?
The code,
The,
the
oh, the code. Oh, for the code. Oh, sorry. For
yes.
this code. Okay, line 2, we create an object called LED, and that LED we are going to assign it to this pin, which is pin number 6 of the hardware. You understand? You remember where we had connected our LED? It's on pin 6. If we change the hardware, maybe let's say we connect to pin 16, we have also to change in the code, so they must be in sync. Then that pin, we are going to declare it as input or output, and because LED is an output device, we are going to say output. It's output. If it was a sensor, we could say in. We could just say in.
Okay.
Okay,
Thank you.
welcome. So let's continue. Mhm. Let me minimize. Okay, nice. So what we are going to do, actually, we are supposed to place the Pico inside the breadboard, but I'm not able to do that with this walkway. I've not interacted with it so much. So let me show you something. So I think you can see my screen well. So this is the, what is it called? A breadboard, but for me I'm using a half breadboard, but it's still okay, the same. So I've just inserted my Raspberry Pi Pico inside here, inside the breadboard. Then we can access these pins by using jumper wires. We have, I told you, we have several types of jumper wires. We have male to male, we have male to female, and we have female to female. So I'm using sorry, I'm using male to male, male to male, male to male jumper wires. This means this is a male and this is a male, because it has a male header. So if I connect, for instance, this is pin number 16. So if I connect, okay, let's say these are pin number 6 randomly. This is pin number 6. If I connect the jumper wire beside that pin, I mean this wire now will become pin number 16. So I can connect my LED. This is my LED. Let's say this is the positive of the LED. I'm going to connect the positive of the LED to pin. So the positive now will be connected to pin number 16. You understand now? Okay. But because I'm able to, actually I'm unable to figure out how I can place I can flip this Raspberry Pi Pico, unless someone knows. I think fit to zone, no? How should I do it? Rotate. If I can rotate, I wish there was a way you can rotate. And I think I can't. Okay, what we are going to do, let's work with it while it's somewhere there. So let me just delete this one and use a half bread half because of the zooming. Yes, so okay, what we need to do, we need to also add LED, an LED, LED, not LED, but LED. So in this LED, we just need to insert it inside the breadboard this way. Is it possible? Yes, that way. Also, we can choose the color we want. Let's say me, I love blue. Is this blue? Even I don't know the blue. This is not blue. Okay, let's assume that is blue. Okay, let's choose another LED. LED. Let's. By the way, we can make a traffic light project even today. So let's choose another color, yellow. I'm not sure if that is yellow or I think it should be. Okay, let's insert this one. Where are we? There, and maybe choose another color. That color. Which color is that? Okay, let's change the color. Okay, we are good to go now. Let me just move a bit. Maybe this. If you have any question, you can interrupt me and ask me. Okay, so number one, what we need to do, we need to, okay, you see this line, this is the cathode of the LED C, and this is C cathode, which is the negative C. So we need to connect the cathode to the ground of the this Raspberry Pi Pico to extend. Actually, breadboard is usually used as an extension, the power extension. Maybe you can picture in your mind that breadboard is a power. It's the same as a power extension. So we're going to connect the cathode to the to our Pico. So what we need to do, we just need to first connect the one, and we should make the connection to be as minimal as possible. So we are going to connect. You see this ground, take it. Actually, ground is usually color coded as black. So if we connect the ground to this line, to this rail, actually the whole of this rail, it will be negative. Actually, it will be ground. So we can draw as many cables or jumper wires as we want from this rail. So from there we can connect now. You see from here we take ground. Okay, we can even loop to the other ground here up. So we take this ground and so we can even pass it there and make it common with this one. So also, and then we should maintain the color at black, but color coding is not a must. So what we need to do now, we need to connect each to ground. So we can do this. We can take this ground from there, then make a connection to that point, and let's do this 0. Also you can connect from this other part, but because we are near this part, we can do this. Let me connect this one to the bottom one, 0. Okay, is there any question up to there? Is it clear? Is it complicated, or is it just pardon on the output and input in terms of sensors, LED, Juma? Okay, I'll explain that. What about the connection? Is there any question? Okay, we have no question. So what we need to do, we need to connect the blue, the first one, I don't know if it's blue, from the digital pin, which is the positive. We can also connect through LED, a resistor, but let's not do that today. So we are going to connect the positive to any GPIO pins. For me, let me just use GPIO 3 because it's the one which came first. So the other positive to GPIO, which one randomly, GPIO 5, and the other one, this one, to which GPIO pin. Let's see, and this, okay, not that one. Not really. So we have connected to GPIO 28. Okay, so what we are going to do next, we are just going to write the code in this part, unless we have any question. Is there any question? Question? No question. Are we good to go? Are we understanding, or we are floating? Okay, we can still utilize this code, but let's write from scratch. Okay, we also need to import time. Nice. So let's say the first LED, I don't know which color is this one, we are going to call it LED 1. Okay, then the second LED, we are going to call it LED 2. What time is it? Okay, LED 2 pin. We are going to, okay, the first one, which pin are we connected to? I can't even remember which pin. The first one, this one, you must be very careful. Pin number 2, so we are going to change from 16 to pin number 2. Okay, if you have any question, I think you can raise your hand, because I will not see you type it there. Okay, the second LED we connect it to GPIO 5, then we say comma pin dot out. Okay, we continue LED 3, we say equals to pin, which pin? I think it was pin number 28, comma, pin dot out. So up to there we are good. Any question? None. Okay, next what we need to do, we need to make something called infinite loop, to create infinite loop. An infinite loop is a loop that will never come to end. So we say while true, then first let's test if everything is working correct. Let's just do a simple task. let's just connect all the LEDs to let's just turn them on. So we are going to say LED1 comma LED1 dot value 1, we pass 1, LED2 dot value, we pass 1 also, LED3 dot value, we pass 1. So let's just try and run that code. Let me just zoom for us to see. Okay, all the LEDs are on except the first one. Is it on? Really? It's not on. Why? Why is it not on? Okay, let's just change the pin, because according to documentation there are certain pins not just which you cannot use for which are defined to be only for inputs but not outputs. So let's just do pin number 9. Change to pin number 9 and try to run again the code. Okay, it's now on. I think pin number 2, actually you should read the documentation, because according to the documentation, pin number 2 you cannot use it for as an input, but you can only use it as an output, but you can use it as input only. Okay, so running simulation, they are all on now. Let's turn them off. You just need to replace the ones with zeros, but let's do some delay, like for example time dot sleep, and we are going to say time dot sleep, and after 2 seconds we need to turn off all the LEDs. Just a minute, let me. Okay, we need to turn off. So let me stop something I'm doing here. Close. Do we want to save? No. Just a minute. Stop.